Hey guys, in this video we're going to be covering activity 6b.2. Our mystery learning objective is I can prove triangles are similar by applying the side-side-side similarity theorem. So the first thing is side-side-side, what does that mean? When we are talking about triangles, we could use side-side-side when triangles are similar if and only if all three, so this is important, not just two, not just one, it has to be all three sides are proportional. Proportional. Alright, what does proportional mean? Well, basically this just means equal fractions. So when you set up the fractions, they all have to be equal. Not just two sides, but all three sides. So one kind of easy way to kind of make sure that you are setting up each fraction correctly would be to find, the smallest side, the biggest side, and like the side that's in between. All right, so one of the things that I would find first is you want to find the small side of one triangle and put that over the small side of the other triangle, right? That same fraction is going to be the middle side, meaning the not the biggest or the smallest side, the one in the middle, is going to equal the largest side. Big side over big side. All right, all three fractions will eventually simplify out to be together. So what we're going to do here is when we set up these fractions, another thing to remember is our scale factor. So just to keep up here, at the top of our notes, right? When I'm talking about scale factor, this is the image over the pre-image. Okay? So when we're looking at this scenario in example 1, I'm going to go ahead and tell you that this is the pre-image and this is the image. All right, so when we're setting this up, I'm going to go ahead and find my smallest side first. So the smallest side, we want, remember, our image to be at the top. So image is over here. Out of these three numbers, 9 is the smallest side. All right, now we look at my other pre-image. And then the smallest side is 6. All right, now hopefully when we simplify all these, we'll get the same answer. So our middle side, so I don't want the biggest side, I want the one in the middle. So that would be 12. Again, going from image to pre-image. Over 8. All right, this is going to equal, I think I use purple, my big side, which would be 15. Again, image over pre-image is 10. Now the reason I have my calculator here is that if you are able to simplify these in your head, awesome. If not, please use your calculator here. I have it right here on my left side, or on the right side, and I'm just going to type those in. So I'm going to do 9 divided by 6. 9 divided by 6 simplifies to 3 halves. All right, this is 3 halves. Does that in fact equal the rest? So I'm going to do 12 divided by 8. That's also 3 halves. And then just triple check. Again, all three sides have to be equal, so I'm going to do 15 divided by 10. And that is also 3 halves. So that's how I can say now that these two triangles are similar by side-side-side similarity because all three sides are similar. So my congruent statement then would be, if I'm just going to go in any order, I'm going to say SUT is similar to triangle. So if I said S first, S is in between my small side and my big side, right? So small side and big side would be X. And then I said U, and U is between middle and small. So middle and small would be W. And T would be my last letter, and the only other letter that I did not use on this side would be B. Alright, so looking at the next example, example number 2, we have one triangle that, again, is not labeled for you. So I'm going to go ahead and say that this is our pre-image, and this is our image. So again, always remember that our K is image over pre-image. Okay, just remember that. Alright, so now we're going to find our small side. So small side of our image would be, smallest number right here would be 22. So 22 over the smallest side over here, which is 32. Alright, is that equal to my next fraction? We can just actually go ahead and simplify that right now. So I'm just going to do 22 divided by 32, so I don't have to keep switching colors. And that's going to simplify to 11 over 16. Alright, now my middle number. So go back to my image. 30 is my middle number. And I'm going to put that over the middle number over here, which is 45. So then 30 divided by 45 is going to equal 2/3. Uh-oh. These are not equal so far. Those aren't equal. And then I think I use purple for the big. Last side here would be 40 over 60. And again, 40 over 60. Eventually I'm going to stop typing these in because hopefully you guys can just divide on your own. This does equal 2/3. But remember what it says above. It says all 3 sides have to be proportional. I only have 2 sides that are proportional. So actually, these 2 triangles are not similar. Not similar. Alright, that's all you can do. You can't say anything else. You can't write a similarity statement because they are not similar. Let's go ahead and look at example number 3. This is going to be my pre-image, and this is going to be my image. Alright, looking at my small side on my image would be 20. I'm going to put that over the small side over here on my pre-image, which is 12. So 20 over 12 simplifies to 5/3. Again, I'm not going to type that into my calculator. Hopefully, you guys now can divide on your own. When you look for the middle, we have 25 over the middle over here, which would be 15. And that also simplifies to 5/3. So good. 2 out of 3 so far. Our last one, big side, would be 35 over the other big side of 21. And that simplifies to 5/3. So yes, all 3 sides are proportional. So therefore, my similarity statement is going to be triangle. Doesn't really matter how we say, you can do them in whatever order in the first set. So I'm just going to go alphabetical. A, B, C is similar to triangle. Now the second one is when you have to be careful. A was between the big side and the small side, right? That's A right here. So big side and small side between purple and red was actually letter E. Then I said B next. That's between red and blue. So red and blue is right here at F. So I'm going to go F. And then I'm going to go ahead and do C. And C goes with D. That's between blue and purple. Alright, so that is my similarity statement. Likewise, we're always going to end with the proof here. We have our given statement. And we want to, I guess, prove that these triangles are similar. So that is kind of the overall proof here. I'm going to go ahead and say this is my statement. And this is my reason. Alright, so number 1 is always the given statement. It tells us that AB is AB is over here at 2. And that's set up to be proportional to DE. And that is equal to BC over EF. So BC is this side, EF is this side, and those are proportional. And then AC is going to be proportional to DF. And this was our given statement. So they gave us all that information. So now what can we say? Well, if all of those statements are true, that's enough to say that these triangles are similar by side, side, side. So I'm going to say triangle ABC is now similar to triangle DEF. And the reason is because of side, side, side similarity. All right, that's what we just did on the other page. And again, you kind of see side, side, sides abbreviated by SSS, so you can also do that. All right, go ahead and work on activity 6B.2. Good luck.